Today we are going to be writing quadratic equations in vertex form and intercept form. So if we are given the vertex and a point, okay, vertex and a point, we have to use vertex form. If we are given both the roots and one additional point, we have to use intercept form. Now if we are given the vertex and both roots, plus any additional information, we can choose which one to use unless it's been specifically mentioned. So we look at the type of equation. It says, write the quadratic equation of a graph that passes through the point and it has a vertex of this. So that means we have to use the vertex form. The vertex form is written y equals a x minus h squared plus k. It did not give us an a value. It did not tell us if it had a stretch or compression, so we need to solve for the a value before we write our final equation. So the general point that they gave us, we're just going to call that point xy. It's not a special point, it's just xy. Now, the vertex is a special point, so even though the vertex is an xy, for vertex form, we're actually going to call this h and k. So now we're going to sub all four of those numbers back into the equation in place of x, y, h, and k. That way we can solve for a. So my y value is 8. I don't know a, so I need to leave a in the equation. X minus h squared plus k. So now all my values are plugged in and I'm going to solve for a. So first I work inside the parentheses. 3 minus 4 is negative 1. Negative 1 squared. So negative 1 times negative 1 becomes a positive 1. And I'm going to write it in front of the a just because it's standard to write the constant in front of the variable. Plus 6. Now how do I get a by itself? I subtract 6 on both sides. I get 2 equals a. So now I can actually write my final equation. So for the equation, I need the a value and I need the h and k for the equation. I don't need the point for it. So my final equation for this graph is going to be y equals 2 x minus 4 squared plus 6. And as I do more of these, I'm going to speed up the process. Write the quadratic equation of a graph that passes through the point. So the point is not a special point, so we're going to call that x and y. And it has roots at negative 3, 0, and 2, 0. Roots are my p and my q. Therefore, I have to use intercept form. Now remember that when I use these forms, I do not have the a value. So my goal is to solve for a before I actually write the equation. So y is 12. I don't know a. 1 minus negative 3 becomes plus 3. 1 minus 2. So I'm going to work inside my parentheses. A times 4 times negative 1. So negative 4 times 1 becomes negative 4a, just because I write the number in front. Now I'm going to divide both sides by negative 4 to get the a value by itself. A is equal to negative 3. For intercept form, I need my a value, I need my p value, and my q value. So my equation is negative 3. X minus negative 3 becomes x plus 3, and x minus positive 2 becomes x minus 2. Now let's decide which one we're going to do. This one gave us a point and a vertex. The point is not a special point, so we call that xy. The vertex is special, so we're going to use h and k. So in vertex form, y equals a, x minus h squared plus k. I would always start off by writing that form so I know where I'm plugging in the numbers. Negative 12 equals a. 4 minus negative 1 becomes 4 plus 1 squared minus 2, since k is a negative 2. Work inside your parentheses first. You have negative 12 equals. So inside your parentheses is 4 plus 1 is 5. 5 squared is 25. 25a minus 2. So now we're going to go ahead and solve for a by adding 2 to both sides. I get negative 10 equals 25a. Divide by 25, and it's okay to have a fraction. The most reduced fraction for negative 10 over 25 is negative 2 over 5. So because I'm using vertex form, I need my a and I need my h and k. So my equation is y equals a. X minus negative 1 becomes x plus 1. And then plus your negative 2 at the end. On this question, this one gave us a point and it gave us x-intercepts. So this one called it x-intercepts instead of roots, but as you know, those are both different terms for the same thing. So my point is going to be called xy. My intercepts, all I care about is the 1 and the negative 4. Those are my p and my q. So I have to use intercept form. So y equals a, x minus p, x minus q. Remember, I have all the information except for a. So 3 equals a, negative 7 minus positive 1, negative 7 minus negative 4 becomes plus 4. So work inside your parentheses. Negative 7 minus 1 is negative 8. Negative 7 plus 4 is negative 3. I have 3 equals. What is negative 8 times negative 3? That becomes a positive 24, and I write it in front of my a. Next step is to divide by 24 on both sides. 3 over 24 reduced is 1 over 8. That's my a value. Remember, the whole point of doing this is because I need to find my a, and I'm going to go back and use my p and my q and my a. So y equals positive 1/8, x minus 1, x minus negative 4 becomes x plus 4. So remember, you have to find your a value before you can write the equation. So we're going to make this one step harder. This one gave us the vertex and the roots. So as we mentioned on slide 2 is that we can use either method. And I'm going to actually do both methods. So if I use intercept form, I have y equals a, x minus p, x minus q. If I use vertex form, I have y equals a, x minus h squared plus k. But guys, your a value is going to be exactly the same for this problem. So you do not have to solve for the a value twice. You only have to solve for the a value one time. Okay? So let's go ahead and do it in intercept form. We have our roots at -2 and -10, and we're going to call the vertex just another point because the vertex is an xy when we're talking about intercept form. So y equals a, -6 plus 10 because we changed the sign, -6 plus 2 because we changed the sign. Work inside your parentheses first. -6 plus 10 is 4. -6 plus 2 is also 4. 4 times 4 is 16. Now, divide by 16 on both sides. We're left with a equals negative 1/2. So my equation in intercept form is y equals negative 1/2, x plus 10, x plus 2. Minus a negative 2 becomes x plus 2. So this is my equation in intercept form. But because I already solved for a, guess what I get to do over here? I don't have to solve for a again. Graphs that are written in different forms have exactly the same a value, no matter which a value, no matter which one you chose to use. Now x. Now I do have to go back and look my vertex, because I'm doing vertex form, is my h and k for vertex form. So x plus 6 squared minus 8. Now, the last question for the day. Here's this graph, and it wants us to write the equation. Did it tell us which form to use? No. What did it give us? Well, it gave us the 2 roots, and it gave us the vertex. So you have a choice here which one to use. I'm going to go ahead and use vertex form on this one. So I'm going to use vertex form to solve for the a value, and then after solving for a, I can easily write it in intercept form. My intercepts are 3, 0, negative 1, 0. My vertex is 1, 8. So for vertex form, this is my h and k, and I can choose any other point. Okay? So I can choose 3, 0. 0 equals a. 3 minus 1 squared plus 8. Now let's go ahead and solve for a. 0 equals, okay, inside my parentheses, 3 minus 1 squared, that's 2 squared becomes 4a plus 8. Well, how do I get a by itself? I subtract 8 from both sides. I get negative 8 equals 4a. Divide by 4, divide by 4. Negative 2 equals a. So the most important thing I had to solve for today was that a value. So in vertex form, y equals negative 2. X minus 1 squared plus 8. There's vertex form. Well, what about intercept form? Well, look how easy this is going to be. Y equals a. Remember, they have the same a value. X minus negative 1 becomes x plus 1. Oops, and actually this is a plus 1 too. And x minus 3. So if I were to graph both of these, they are the exact same graph. This is the graph. They're just written in 2 different forms. Hopefully this video helped you understand how to solve for a so that you can write the equations in intercept form or vertex form.